Good morning, everybody. Today, actually, I'll be discussing on a particular material which normally, uh, in the industry, people are not using it, but it is picking up its uh, popularity because of its different advantages. Now, the question is that, uh, first of all, we have to understand that why this particular concrete is a bit different from your conventional or traditional cement concrete. You see, it is written alkali activated concrete. That means it is some concrete where conventional cements are not used. Rather, we use some waste material like fly ash or GGBS, metackaolin, or some other polyolinic material, and also some other types of material, not only like fly ash slag. There are at least 9, 10 sources are there. So, if you activate them, if you activate those uh, materials with alkali, then what will happen that those particles, maybe fly ash or DGBS, that get dissolved. And once it get dissolved, after that, slowly it will solidify. I'll explain you later on. And uh, another thing is that means you are not using traditional cement. That is the most important part of it. Second is you are using waste. That means your source material is just a waste, fly ash, GGBS, because these things are, normally we are dumping somewhere, and maybe sometimes we are using for road construction or filling up a particular place. But only problem is that that uh, if this leaching takes place and if the um, that kind of materials, rather you can say the chemicals, if it mixed with the groundwater, that means if those things uh, are reaching to the groundwater level, then what happens? Groundwater is polluted. So, dumping is really a big problem. So, keeping that thing in mind, people are thinking that how we can use those waste materials like fly ash uh, and blast furnace, whatever it is, it's abundantly available. Uh, in many situations, you will find in many states of our country, uh, they said that if the thermal power plant is placed in a particular place, within 50 kilometers, uh, you can't take out soil and make brick. You have to use fly ash or whatever they are generating, the waste, and then you can make brick out of it. So in this way, they are imposing certain government rules, and the reason behind is that to popularize the this kind of bricks, which are equally good like mud bricks, burnt mud bricks, or any other kind of bricks, and you are not using conventional cement. So that is the basic idea behind it. That why we should go for alkali activated concrete and using waste. And second thing, that the moment you are uh, thinking about a particular material and you are trying to convince your client that it can be used, then immediately we will ask you about its performance. That means its strength, in the fresh state, its workability, its durability, and there are many other properties which they expect out of it. Now, I'm not talking about only brick. It may be used in case of building construction, road construction, anywhere you can use it. Or even many situations, maybe later on I'll discuss someday about soil stabilization. So, the basic idea is that the inflation of the waste and to make a material uh, which has got a very high performance in terms of strength, workability, durability, and then automatically people will run after it because cost will come down. You are getting better material, your dumping problem is solved. Then from dumping to groundwater, pollution, those things are solved. So why not? And the other thing you have to remember that whenever we are trying to avoid the conventional cement, that means we are avoiding the huge amount of energy which is required to manufacture conventional cement. You can avoid that. So that is a big thing. And the second thing is that when you are manufacturing conventional cement, huge amount of carbon dioxide is coming into the atmosphere. And you know that the uh, carbon dioxide is one of the culprits uh, against your global warming. So, keeping this thing in your mind, now if I slowly proceed to the subject, and in your mind frame, you keep these sentences. Means whenever I'll be discussing something, keep these initial sentences in your mind frame. Now you see, this is something what I already told you that regarding carbon dioxide emission and all these things, and about the energy requirement, that also I told you. So these are the important aspects which one should keep in mind, which I have already told you. Now you see, this is a particular data from which you can easily understand that what is happening throughout the world. Now this UN World Meteorological Organization (WMO) they published several documents in different journals, publications, and they are actually just giving this figure. So it's quite high, and you can easily understand that from 1960 how it is rising. So that is we are very careful of it. Should be careful of it, and just see they are expecting about 4 degrees centigrade temperature rise in 2060. So 1 degree increase in temperature creates a lot of problem in human health, and 4 degree means it's too high. Now you see, what is alkali activate concrete? I have already to explain you. Alkali activate concrete is a class of aluminum silicate binding materials, synthesized by thermal activation of solid aluminum silicate based material such as I told you, fly ash, EBS, in presence of alkali, metal, hydroxide and silicate. Now, you see, whatever it's a general definition. It's not that always you have to go for thermal, curing. It's not required. Thermal activation is not always required. Now, we are rather going for water curing, which is, extremely acceptable to the common people, means engineers. And when you are saying metal oxide, sodium hydroxide or potassium hydroxide, in this way we can use it. So we have used different types of methyl oxide, and we studied the reaction pattern and also the microstructural part of it. And then we have to really decide whether we will go for sodium hydroxide or potassium hydroxide separately, or we will blend it together and use it. Whatever you do, that is to have a better performance in terms of strength, workability, and durability. And also, when you are going for a curing, heat curing, then 60 to 90. It is also, you cannot say it is 60 or 80 or 90. It depends on the composition of the fly ash, composition of the GGBS. But as we are working for a long time, uh, maybe more than 20 years, so we have huge data through which we can always give our expertise that for this particular composition of fly ash or GGBS, the curing temperature should be around this thermal activation. But only thing that you have to remember that if we can avoid thermal activation, better. And that's why we are presently, our expertise is mostly on water curing. We are trying to avoid heat curing. And how that I'll explain this on. Now you see this, what is happening. First of all, the fly ash or the GPS, whatever you have taken, and you have added alkali to it. Is it not? Or you have added some silicate to it. Or maybe alkali silicate both. Now what will happen? That dissolution takes place. And this silicate species is activating solution. So what will happen? Rearrangement and exchange between the dissolved units. Then what will happen? Gel will form, gelation. After that, solidification and hardening. And after that, this gel formation will continue. And in between, if we add sand or stone chips or whatever coarse material or fine aggregate you want to use, you can put it. And if you mix it properly, you will get concrete. Now you see that the properties of alkali activated concrete, I told you it is superior than conventional concrete. So today it will not be possible for me to explain every aspect of it, but I can just give you an outline where we have studied, we have found, we are now in a position to recommend. And the most important thing is that we have studied in our lab, that is in Haldia Institute of Technology, in our civil engineering lab, and our teachers are extremely expert in this particular subject. So if anybody comes for any suggestion or anything, they can straightway come to Haldia Institute of Technology, civil engineering department. They can meet our teachers, experts, and they will get the solution. So it's not that we are telling something out of others' research. No, we are telling something out of our own research. And own research means not only research, it is also published in good journals or accepted. And also, we are involved in this geopolymer code activity or geopolymer, or you can say alkali activated concrete, this kind of research or conference everywhere. So don't worry, if you need any expertise, you can always contact us. Now, simple production technology that you can easily understand. Then earlier development of higher mechanical strength. If you want to develop your strength within 2 days or 1 day, you can get it. You will get it. Fast curing. Very little shrinkage and creep. It's a big advantage. Over conventional cement concrete. Extremely good resistance to sulfate, chloride, and alkalis, and also acid. Now, this fire, or if it is under high elevated temperature, up to say 1200 centigrade, we have found that it is very good. Because if you heat something, then automatically it will lose its strength. But if it is losing strength very fast, like your conventional cement concrete, then it is of no use using for furnace lining or some other place where the temperature involvement is more. So at least 1200 degrees centigrade we can always recommend. Then freeze-thaw resistance, no alkali aggregate reaction because alkali is consumed there. How come there will be free alkali? So there will be the aggregates are alkali reactive. Then there will be no alkali aggregate reaction and highly durable because if it complies to all these good properties, automatically it will be durable. Automatically. So that is why when I'll get time, I'll show you the properties of conventional cement concrete against this alkali activated concrete. And I think that after that, your only choice will be this alkali activated concrete. Now you see, when you are rather trying to make a mixed design, then it is not the way we do it for cement concrete, which is available in IAS 10262 or SP 23. No, not like that. The method is totally different based on chemical composition of the source material like fly ash or GGBS. Also, alkali is concentration, really get its concentration. So, these are the aspects. So, basically, the chemical composition parts. Now, what we have done after our research, we finally developed the typical tables and also the graphs so that anybody can just have an idea about it and he wants to get a particular type of alkali activated concrete, which we normally say tailor-made alkali activated concrete. Then he will just consult those tables and charts and he will be able to arrive at a particular mixed proportion. And then that may be his first trial, maybe his second and third trial, he will be or she will be successful. Right? Now, these are the things, it's available in the book form, it's not in paper form. At least we can give you 3 books on this, on alkali activated concrete, where all the detail what I am saying or what I will be discussing later on, if I get time, then we will get from those books. It is internationally published books. It's not that it's not available. It's available in Amazon, so you can easily get access of that. So alkali content is very important. Then silica content, right? Then water binder ratio. Always water binder ratio is a very important parameter that you know for normal concrete, is it not? So if you can keep the water binder ratio as low as possible, that is the best, right? Because you have to understand one thing, that for normal cement concrete, the water is required for hydration. For this kind of concrete, if we use fly ash, then hydration is not coming in the picture. But when you are adding, say, blast furnace slab with it, so there is some calcium. And naturally, some water is required for the hydration of that GGBS, the slag. So, depending on the source material, whether only fly ash or GGBS or fly ash, GGBS, silica, depends. You will be able to assess the water demand. And we want to put that amount of water only, not more than that. But even then, some additional water is required for the flow too, because the concrete, if it is not flowing, the water quality is not high, then sometimes we face problem in casting. Now, for that also we have solved the problem, because there are so many clusters and superclusters available, number of clusters available. We try to use those clusters and try to find out which one is compatible to this particular type of concrete. Use that particular type of admixture or supercluster or whatever you're using at the agents, and you can easily keep your water cement ratio at the lowest level. And that's good for durability, strength, everything. Now, highest content, this is important obviously. Why? Because if you add, slab, then whether it is 50-50 or 75-50, 25, so, that is why this is important. Curing temperature, I'll come to later on, that curing temperature, you must start from the room temperature to 100 degrees centigrade. But if you increase the curing temperature, means you will be achieving strength faster. No, not always. Beyond a particular temperature, you may not get the advantage of keeping your temperature at the high level. Because if you do that, then what will happen? Instead of 90, if you keep it 100, then your energy consumption will be more. And I told you also that we are now 100% sure about water curing. So, for pre-fabricated industry, in abroad and also in our country, people are going for still thermal curing. But slowly it will be replaced by water curing. It is already replaced. Duration of thermal curing is very important. How many hours? How many days? So, if you think that if you keep on cure under high temperature for a long time, it's good. No, not at all. So, you have to be very careful about these parameters. Now, you see, these are the outcomes in brief. Because I cannot show you the outcome in detail within this short time. I'll definitely request our coordinator to give me some chance to give you more detail about it in future. Now you see, if it is the compressive strength, tube compressive strength, and this is alkali content, right? 0.48, 0.52 like that. Alkali content is normally in terms of the ratio. But you can even alkali content you can express in terms of percentage. You can also express in terms of molarity. So that's not an issue. If you add more alkali, the molarity will be higher. So, and also this ratio will be different, higher. So if you do that, if you add alkali more, then the strength will slowly increase. You see, it has gone up to 50 almost. What a matter of joke. Now, question comes that what will do then? Shall we increase the alkali content to any extent? No. If you increase the alkali content, what is happening? That as the alkali is stronger, if the molarity is higher, that means the particles will get dissolved quickly and you will get quick result. But it is not only depends on the alkali molarity. It also depends on particle size. Because if the particle size is much more finer, instead of 75 micron, it is 40 micron, then dissolution will take place faster. So anyway, means it will increase definitely, but for not all the types of particles. It depends on particle size and all, and also the if we go for the blended source material, fly ash, GP both, then it may be slightly different. But everything is documented. Don't worry that we are not discussing anything, any single word taken from some other's word. It is done in Haldia Institute of Technology in our civil laboratory, and our professors, they have developed it. So don't worry, if you just come and you will be able to understand what is happening here. Now you see, this is the kind of thing from which you will be able to understand one more thing. See, this is the micrograph from scanning electron microscope. Now, if we see that, see the alkali content is more here. It is 0.62. It is 0.46. Right? Now, just see, just by seeing the photograph, the micrograph, you can see this is denser. No doubt about it. That means if your alkali content is more, obviously the microstructure will be denser. But only problem is that, as this particles will dissolve first or faster, then what will happen? The workability will come down. So you may have to, if you go for high alkali content, you may have to use plus layers. Sometimes DGBS is also helping in getting higher workability. And anyway, these are the things. Normally, it is the expertise is not available, but it is there in our institute, so you can always use it. And these are, the X-ray diffraction pattern. That means whatever you got it here, after that, if you do this X-ray diffraction pattern and all these peaks, they are denoting some kind of compound. Automatically, if a new compound forms, it will indicate. They are under this condition, under this kind of blending, under this kind of temperature, this new compound forms. And if it is in favor of our good properties, then why not? And if it is not, then we will try to avoid that. See, this is another one, that is the water and this solid ratio. Solid means DGBS fly ash. If you take both or fly ash, only fly ash you can take. And at a particular ratio, it is giving you the very high strength. But beyond that, like normal concrete also, it is not giving. So 0.3, we consider it's on the higher side. But one can even start at 0.25 and using plasticizers, you will be able to, or she will be able to achieve high performance alkali activated concrete. So I think this is a very important graph to you, and also this curing days are also important to you. Everywhere 0.3 is showing the maximum. And you see, this is another one that if we add sand, then sand fly ash ratio, it may be 1, 1.5, 2, like that. Obviously, if you increase the quantity of sand, then what will happen? It will come down, right? But it is giving you 50. Do you need 50 for your plaster? I don't think so. So that's why you see that in most of the situation, you will find that you can make plaster properly, highly durable, impermeable. Strength is also very high. What else you want? Then you see, this is another way of understanding that it's a good material. That composite strength versus curing temperature. Right? Curing temperature, see, it's like that. So around that, around say 85, see, it's giving this. After it is flat. It is flat. Right? What does it mean? It means that even if you increase the temperature further, you will not get any advantage. Right? If you go for thermal curing. This is another way of understanding duration of curing. If we increase the duration of curing, 10 hours, 20 hours, 30 hours, like that, say beyond a particular stage, say 48 hours or 50 hours, 2 days, you are not going to get advantages, right? So these are the things you have to remember when you will be recommending for curing temperature and in thermal activation, and also the curing duration. You see, when you are using fly ash and blast furnace slag, why? Why not only blast furnace slag, or why not fly ash? Yes, we can use it. But when you studied, we found that fly ash has got some advantages. Blast furnace slag has got some advantages. Again, both has got their own disadvantages. Now, if we don't add, DGBS, the slag, then water curing is not really possible. Because we want that water should take part in hydration to some extent. That's not required for fly ash. But if there is DGBS, obviously water is a bit required. Second thing, that when you are using fly ash, then you are getting aluminum silicate gel. It's very good. When you are using slag, calcium base, naturally you are getting calcium silicate hydrate gel. Naturally, if we compare these two kinds of gel, then obviously the aluminum silicate hydrate gel is better. Not hydrate, aluminum silicate gel. Now, better, fine. But in terms of workability, in terms of water curing, if we join hand with slag, what is the problem? Absolutely no problem. Because if you want to get a better acceptability, water curing means better acceptability, then one should go for it. Workability, for better acceptability. So that's why these two materials, I think you can easily understand that both are required. Previously, people used to talk about only fly ash or only GGBS, but now they have realized that both the materials, if they are good friends, then they will be able to produce better materials. Now you see, the material which normally we are using, I'm not going to detail of it, 6-sodium hydroxide, it's coming in pellet forms. Then we have to add water and then it gets dissolved. Sodium silicate, it comes in the form of liquid. That is in the jar we are supplying, and we have to use from there, right? So we don't have much time. Now the fly ash is, you have seen this kind of fly ash in thermal power plants, right? And you see, this is a typical mix. It is full fly ash, 85% fly ash, 75% fly ash, and like that. And these are the alkali content, silica content, and all like that. Okay? So this is the mixed detail, right? In a particular research. If there are 50 trials, then this is one of the trials. Now you see, just see that these specimens are exposed to 500 centigrade temperature, 700, 900. So obviously the strength is coming down. Obviously, if you expose to 500, the strength will come down. Right? But you have to remember this way, that when it's 700, when this is 900, it's coming down, but not much. So if you target for 50, and it is coming down to 35 at temperature 900, absolutely no problem. We have to keep our target strength very high if we really want to use it in case of your alkali activate concrete under elevated temperature. Or even fire, we have not tested it, we will try to test it. See, this is also coming down as quantity of slag is increasing. That will happen. That will happen because the aluminum silicate gel is superior than calcium silicate hydrate gel. So automatically, in presence of slag, the calcium silicate hydrate gel will be more. It may dominate, and for that it may come down, but not much. So you see the kind of things which is happening in case of jail and all these things. Already I have discussed. Whatever written here, you please go through it. It is already, I have discussed. So no need, repeating those things again. You see, this is also, another kind of expansion that we found for that particular type of fly ash that 30% addition of GGBS is the best. But don't think that always it will happen like that. It depends on the composition of fly ash, the fineness of fly ash, the composition of transparent slag, its fineness, and these are the things. Now, even if you want to expose it to very high temperature, then what should be the blending ratio? So all these things, we have done in different stages of the research work. Because I think that this is for last 20 years. So these are the procedures. When you will do something in the laboratory, those who are researchers, they would like to, know the procedure. See, this procedure, if you just find out some paper of mine or my teachers in HIT, you will find it. Or if you call us, because these are the things one should do it in the laboratory, and then its advantage, disadvantage, or what is happening in summer, what is the disadvantage in winter, they will be able to realize. But anyway, you have to work on it. See, this is fly ash slag ratio, and this is this ratio. Just see. These I have already shown you in different form. This is another set of data. This is the flow. Just see, flow has gone to 200. It is not in slump. It is done in the flow table, like you are doing it for self-compacting concrete. Similar kind of thing. In self-compacting concrete, if it is more than 180, it's very good, excellent. So that you see in 40-60 we got the maximum because of more slag. Less slag we got around 140 or 35 like that. So this is the advantage of adding slag. Again you see this is porosity, apparent porosity, and this is also you see because of fly ash, it is giving very high. Not my point. Water absorption, just see. This, 16, 14, 10, but the slag quantity is increasing. If the slag quantity is increasing, obviously this is a disadvantage, but we will not do that. We will make a balanced design so that we should be able to go for water curing, we should have a high flow, and at the same time high strength, high durability. So everything is within our hand. So we have to use our understanding about the subject in a better way. Just see the UV value, ultrasonic pulse velocity value is very high. Normally you say 3.5 is good, 4 extremely good, 5 means fantastic. It is even 4.9. Not a single data is, much less. So how can you say that it is not that good compared to cement concrete in terms of UPP value? So that's why my suggestion is that please go through these things, try to appreciate it, and if you want to use it, the best thing is that you call some teachers of our department, because almost all are in this area, working in this area, and get the suggestion from them. So absolutely no problem. We are free to give you suggestion. This is again water absorption due to slag. It is increasing, water absorption increasing, right? But if it is 14 days, then it is decreasing. Obviously, more gel formed and the pores are filled up with those gels. These are the X-ray graphs that depending on the just you can say the proportion of fly ash to slag, how the things are changing. This you have to study. I have given it just to study. Make it the screen still and study. This is another one, 90, 55, 15 means slowly you are increasing this slag and see how this microstructure is changing. How the microstructure is changing. Just see. Even 50-50. Some crack has developed. Okay. So these are the things you have to understand, that you have to get a good microstructure, lower porosity, higher strength, high workability, water curing, all these things you have to meet up. These are the other thing, 40-60. So 40-60 definitely I will not prefer. Now these are the conclusions. You can make this screen still and just go through it. Almost everything I have already discussed. Everything. Whatever it is there, it is more or less I have discussed. More or less I have discussed. Only thing, if you want to see it again, just make your screen still and just read it out. So all these things, whatever I have written here, summarized, that already I have discussed. Now this is very, sometimes we say that one should never be complacent, but should be ever alert for new problems, new solutions, and new opportunities. Thank you very much for your attention.